Hi guys, so today we're going to take notes on page 37 in our ISNs representing proportional relationships. So we've talked about proportional relationships before in class and through homework, but we're going to talk about how it looks like when we're using tables, equations, and graphs. So go ahead and open up this ISN or this foldable and you'll see these couple of examples right at the top, or a few examples. A proportional relationship between two quantities is a relationship in which the ratio of one quantity to the other quantity is constant. Okay, what does that mean? Well, let's look at it. 2 over 1 is equal to 10 over 5, right? So what this means is we're saying when you take the numerator and divide it by the denominator, you get a 2 here. If you do the same thing here, take the numerator and divide it by the denominator, we get a 2. So the ratio of one quantity to the other quantity is constant. Our constant in this example is 2. Let's look at example 1 down here. Is there a relationship in the table proportional y? So our independent is always going to be our top value, and that's also our x, our independent. Dependent, sorry, it's kind of cramped in there. So our x values always represent independent values, and then our y values, y's are always going to be on the bottom, they will represent our dependent values. So whatever you get down here is going to depend on your independent value. So the independent value can be anything. However, dependent values have to be what whenever you enter your value of x, then you'll get your value of y. So let's look at it. We're going to divide our y by our x. 60 divided by 1, just like we did over here, we took our independent and divided by our dependent. So 60 divided by 1, or sorry, we took our dependent and divided by our independent. Get 60. Over here, example 2, 120 divided by 2, 120 divided by 2 gives us another 60. 180 divided by 3 gives us another 60. 240 divided by 4 gives us another 60. So our constant in this example is 60. For all four of these, our relationship or a constant is 60. So yes, it is a proportional relationship because we have a constant of 60 between all of these relationships. Okay, awesome. A proportional relationship can be written as an equation in the form of y is equal to k times x, or kx, where k represents the constant of proportionality. The graph of a proportional relationship is always a straight line that goes through the origin 0, 0. So if we look at a coordinate plane just like this, remember our x-axis is this one and our y-axis is this one. So x, y, remember the first one's always x and the second number always represents y. They're both 0, so you don't go left or right on the x-axis. Stay right there. And then on the y-axis, again, you don't go up or down. You stay right at the center. So your origin is this dot right here where both of your x and your y axis meet. Before we move on to the graph, let's go back to this one right over here. Y is equal to k times x. Well, let's look at some of these examples down here, and it says circle all of the equations that represent proportional relationship. If it is proportional, identify the constant. I'm going to erase some of these words right over here because we need space. Okay, so if you look at all 4 of these examples, there's only one that does not fit. Go ahead and pause and see if you can figure out which one is not a proportional relationship. Well, hopefully you guessed this one because it has that +1 at the end. So that is why it is not a proportional or not a representation of a proportional relationship. Okay, so all 3 of these are proportional relationships. And the second part of that is identify the constant. So for number 1, the k is going to be 12 because y is equal to a number k times times x. So that k is 12 in this case. Over here, y is equal to a number 0.75. So our constant k is 0.75 times x. And then the last example, k is equal to 1/4, or y is equal to k times x. Okay, so now let's go back to the graphing. The graph of a proportional relationship is always a straight line that goes through the origin 0, 0. So, does the graph below represent a proportional relationship? Yes, it does, because it is a straight line that goes through the origin. Again, remember, the origin is where both your x and your y values or axes meet, and this line goes straight through it. Okay? The line goes through the origin. Okay. Next. Okay, example 4. That was wrong. Okay, example 4 says Dakota earns $8 an hour at his part-time job. Okay, so again, our independent is going to be on the top, which is also our x value, and our dependent is going to be on the bottom, which is also our y value. So independent, in this case, is going to be the amount of hours he works, because he can work however many hours he wants, right? Hours is our independent value, and dollars, or earnings, is our dependent value, because that depends how much money he makes depends on how many hours he works. So if he works 1 hour, he's going to earn $8. If he works 2 hours, he's going to earn $16. Go ahead and fill out the table for 3, 4, and 5 hours on your own, and then figure out what your k, your constant, is. And after you figure out your constant, write out your equation y is equal to k times x, where you fill in the value for k into the equation. So you should have something that looks like this. Y is equal to a number times x. Okay? And then after you figure that out, go ahead and graph your independent values and your dependent values. Again, your independent value, which is your hours, is going to be on the bottom. Hours is represented by x, which is your independent, and then your earnings in money made is going to be dependent on the y-axis. So if we look at these first 2 points right over here, we have our x value is 1 and y value is 8. So my first ordered pair is 1, 8. Well, let's graph that. If this helps, writing out x, y, go ahead and do that. So my x is 1, 2, 3, 4, and 5. And then we're going to have, I think, let's go by fives. 5, 10, 15, 20, 25, 30, 35, sorry, 10, 5, 10, 15, 20, 25, 30, 35, 40, and 45, and 50. Sounds good. So if we look at this now, the first one, 1 hour, he earns $8. So 1 hour, for every hour he works, he earns $8. So that's going to be just below 10. So that's my first dot right there. And then 2 hours, he earned $16. 2 hours, he earned $16. So that's going to be just above 15. Go ahead and graph the rest of this. And then, so for 3 hours, 4 hours, and 5 hours, and then connect those dots. And remember, if he were to work 0 hours, how much money is he going to earn? 0 money, right? So your graph should go through the origin, because when he works 0 hours, he's going to earn 0 amount of dollars. Okay, example 5. Now they've only given us the graph to go off of, right? So we're going to have to fill in our table and write out an equation using just the graph. It says our independent value in feet is our independent value inches is dependent on our feet. So for every 1 foot we have how many inches? 12, right? We have 12 inches for every 1 foot. So again, our feet. Feet is our independent value, or our x value, and our inches is our dependent value, or our y value, because however many feet we have will tell us how many inches we have. So if we have 1 foot, well, we will get 12 inches. So if you look at this, there's a dot at 1, there's a dot at 2, there's a dot at 3, 4, 5, 6, and 7. I want you guys to pick any 4 of these remaining dots and fill out the rest of the table. Okay, any 4, it's your choice, but it has to be one of these 5. 1, 2, 3, 4, 5, 6. One of these 6 dots, okay? So we can say there are 12 inches in a foot, right? Well, go ahead and find your K, your constant, using the table, and then write out your equation. Fill this out. What is K going to be? So you're going to write out y is equal to a number K times X. And then I think you'll be good. Go ahead and fill the rest of this out, do the equation, do the rest of the graph, and then fill out the rest of the table and the equation, and have a good night.